Hello and welcome everybody. Myself Sudarshan, roll number 20EE10075, and in this video I'm going to demonstrate my digital electronic circuits lab experiment number 1. So the aim is to get familiarity with 7-second display and display decoder or driver. So let's go to part 1. This is the part A, and the aim is to observe the blinking of the LED by manually connecting with A, B, C, D, E, F, G terminals. So this is the 7 segment display which is connected to the input voltage of 5 volt with a resistance of 330 ohm. So we are using here the common anode mode LEDs which N junction is connected to the A, B, C, D, E, F, G terminals. So to blink the LED we have to connect those terminals to the ground. So I have used here the logic gates, logic switches. Suppose we have to show 8, so for that all the LEDs have to blink. So here all the LEDs are 0, so when I run it, it's showing 8. Suppose I have to display 1, for that B and C has to blink. So for that B and C, they have to 0 and all the rests will be high. So it's showing 1. So in this way we can display other numbers also. So let's move to part B. Here I have connected one IC, that is IC7447. This is a BCD to the 7 segment display decoder. That means this A3 is the input where we have to put the MSB, that is the most significant bit, and A0 is the least significant bit, that is LSB. So suppose the binary number of 8 is 1000. So when I put 1000, then it should show 8. So let's check. So here also I have used that logic switches. So 1 0 0 0. So it's showing 8. So our circuit is correct, and in this way also we can also design other numbers. Now part C. The aim is to test the Rbi and Lt input. So in IC7447, this is the ripple blinking output, this is the ripple blinking input, this is the LT test. So when the test is high and the RBI is low and all terminals are 0, then it will slow, nothing it will show. And when the RBO is high, the test is 0 and the inner A1, A2, A3 are 0. So then all the LEDs will blink. So this is the truth table that we have to verify. And let's go to part D. So here we have used a pulsar. Along with that, we have used this IC7493. So this CP0 is connected to the pulsar, which is receiving the input, and CP1 is connected to the Q0. This is the master set pins, that is MR2 and MR1. When both will be high, they will reset this Q0, Q1, Q2, 3 to 0. So here, let's see what's the display. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and after that it's showing some garbage values. So here the aim is to get modular 10 counter by using IC7493, but IC7493 is a modular 16 counter. So after 9 it's showing some garbage values because it has to show till 16. So after 9 it will show 10, 11, 12, 13 and 14 and 15. So but those values can't be displayed in this 7 segment display, so therefore we are getting some garbage values. Now let's proceed to part E. The aim is to get different modular numbers by using any combinational circuits, that pulsar and 7493 IC. So I have used some combinational logics to design different numbers. So let's check one to get modulo 6. So this is the modulo 6 counter. So let's check 0, 1, 2, 3, 4, 5, 6 and 0. That means it should show 0, 1, 2, 3, 4, 5 and it's going to 6 and again suddenly coming to 0. That means when this A0, A1, A2, A3. That means the MSP is 0, then 1, 1 and 0. This should be the master set pins should put this Q0, Q1, Q2, Q3 as 0, so that we'll get the modulo 6 counter. So that's the idea, and I have also designed other number counters also. This is the same part E. So here I have designed modulo 7, 8, 9 and 10. So let's check 1, 2, 3, 4, 5, 6, 7, 8 and 9 is coming to 0. So it's working. So this is all about part E. Now coming to part F. So here part F, instead of using IC7493, I have here used the IC7490. So it has two extra pins, that is the MS and MS1 and MS2. This is the master set pins, and the same pulsar I have used here. So here also the aim is to get different modular numbers by using IC7490. But here one restriction is we can't use any combinational logics. So let's check one. Suppose to get modulo 5, 0, 1, 2, 3, 4, 5 and again coming to 0. So it's properly working. Now let's go to part G. So here the aim is to display 4-digit counter using 4-7 display board and IC7490. So here with one specification that we have to neglect the trailing 0. That means when it will show 0, 1, 0, 0, 100, that means it should not show the 0 here. So for more convenience, I have used those circuits and connected those combinational circuit to the RBO such that the trailing 0 can be neglected. So let's see after simulating. So the trailing zeros are neglected here, but the zeros here it's showing. $100, so 0 is showing, and here the trailing 0 is not showing. So the circuit works properly. Now coming to the last part, that is part H. So here the aim is to measure the voltage and the current of this digital circuit. So for that the simulation mode is in analog mode. Here's the ground. Let's simulate the circuit. So here to measure voltage, so this is the plot of the voltage that's showing 5 volt, and then multimeter also it's showing 5 volt. Similarly we can measure the power as well as current. So for the current, suppose I is minus 8.538 milliampere in the multimeter is showing, and this oscilloscope also it's showing around minus 8.5. So in this way we can measure the voltage and the current. So this is all about my experiment number 1, DCLR. Thank you.